All right, now we are on to the next type of cell, electrolytic cells. Electrolytic cells are not spontaneous. They're still a redox reaction, but they're not spontaneous. So they literally cannot happen on their own. They must be forced. And how do you force it? Use a battery. So electrolytic cells are used for electrolysis and for electroplating. You absolutely must see a battery in the diagram. This is the most common way to see a battery in the drawing, is to see this short line followed by a long line. You might see an actual battery. It might say voltage, and you should know that volts come from batteries, okay? Usually there's no salt bridge. You still need an electrolyte. You still need a liquid because the ions still have to move around, but usually they're in the same container. Okay. Now, having a salt bridge doesn't mean that it's not, because you can see this battery, that is what indicates it's electrolytic. In this case, for an electrolytic cell, the energy change goes from electrical to chemical. So we're taking that electrical energy from the battery and converting it into chemical. So electrical to chemical. It also needs a wire because the electrons are going to flow, and the electrons are still going to flow from anode to cathode, just like before, okay? But here's where there's a change. Remember the anode was negative, like an anion? Well, because I put a battery in here to force a reaction, the charge switches. So the charge of the anode is positive. It got switched by the battery. The battery was like, I don't think so. But everything else stays the same. The anode is still oxidation. The anode still loses electrons. The anode, since it's oxidation and loses electrons, the electrons are still on the product side. What switched? Just the charge. The battery switched the charge, okay? Essentially what the battery did is made the cathode become the anode, okay? But the charge was kind of the same. So that's one way to think about it. How I just remember it usually is the anode is oxidation always 100% of the time, but in an electrolytic cell, the battery's like, the charge switches. So we're still losing electrons. The mass, the size is still decreasing. The number of atoms, which is related to the size, is decreasing, and the number of ions is increasing. And here's the other thing. The anode is going to be lower on table J. Wait, what? Okay, so remember, there's the switch, okay? So what happens is in an electrolytic cell, what was supposed to be the anode becomes the cathode, and what was supposed to be the cathode becomes the anode. So the anode is actually lower, and the anode has a positive charge. So those are two key differences. Let's look at the cathode. All right, so the cathode is negative. Again, that charge is switched because of the battery. But then everything else, like cathode, behaves normal. It's reduction, red cat. It gains electrons, GR. The electrons are on the reactant side, okay? Also in a cathode, because they're gaining electrons, the mass, the size will increase. So the number of atoms increases and the number of ions decreases. But normally, remember, the anode is higher, but because of the battery, it's like, So the cathode is actually the higher metal on table J. It's going to make more sense when we do some examples. All right, so here's the first example we're going to do, but I'm going to do it on paper so you don't see my chicken scratch. Okay, I have some questions, but before I even look at the question, I am going to look at the diagram and label everything I can possibly label on the diagram. So I see this says current source. So that tells me this is an electrolytic cell. Okay, I have a silver electrode and an object to be plated. Now it doesn't tell me what the other one is, okay, but it does show me the electron flow, right? So the electrons are going this way. So the electrons, remember, always go from anode to cathode. Okay? The anode is always oxidation. The cathode is always reduction. Reduction means gaining electrons. So the mass and the atoms will both increase, but the ions will decrease. And then on the anode side, we're losing electrons. So the mass and the atoms will decrease, but the ions will increase. Now, what was the switcheroo? The anode, which is normally negative because of this battery, reverse, reverse. The anode becomes positive, and the cathode becomes negative. Okay? So, what is the name of this type of cell? Well, I already answered that. That is electrolytic. How do I know? There is a battery in the circuit. A power source, could say a current source. There are two electrodes in the diagram, the silver electrode and the copper piece. Oh, it told me this is copper. Label correctly in the diagram which one is the anode and which one is the cathode. Done. What is not the same for a voltaic and electrolytic cell? So oxidation, reduction, chemical reaction happens. Well, yes, that's in both. They have two electrodes, anode and cathode. Yes, that's true in both. They produce voltage and an electric current. And electrons flow through an external circuit. So the only one producing, so remember the energy transformation in electrolytic, it is electrical to chemical. In the other type of cell, it is chemical to electrical. So this is not the same. Okay, there we go. All right, here's another example, but again, I'm going to do it on paper. Okay, here's another one with a bunch of questions. What I'm going to do is label as much as I can in this diagram before I do the questions. The questions are so much easier when you do it that way. All right, are you ready? So look at this power source. What does this tell me? That tells me this is electrolytic. Okay, I have two metals. I have Ag and Ni. Okay, so let's look right here. Ag, and where is Ni? Oh, right here. All right, so Ni is higher. Now, normally in a voltaic or galvanic cell, this tells me this is oxidized. But see this battery right here? It goes reverse, reverse. So this Ni is the one that is reduced. So I'm just going to write it down here to make it a little less confusing. Ni and Ag. So the Ni is reduced and the Ag is oxidized. Okay, so the oxidized means it is the anode. The reduced means it is the cathode. Remember, because of that reverse, reverse, the anode is in fact positive and the cathode is in fact negative. So the anode will lose electrons, which means mass, and atoms will go down and ions will go up. And the cathode gains electrons, so the mass, which is the same as atoms, that is going to go up, and the ions will go down. Electrons are going to flow always from anode to cathode. So this was the Ag piece. So it is going to go from here. So the electrons are going to go this way to the cathode, to that nickel piece, right? Okay. Identify the cathode. So what is the cathode? That is nickel. State the purpose of the power source. It's to force the reaction, right? This is not a spontaneous reaction. We needed that battery to go reverse, reverse. You must happen. State in terms of energy why this is an electrolytic cell. So I'm going to say electrical energy is converted to chemical energy. So that explains why it is electrolytic and it uses energy in my answer. Explain in terms of Ag atoms and Ag plus ions why the mass of the silver electrode decreases as the cell operates. So the number of Ag atoms decreases, but the number of Ag plus ions increases. I already knew the mass went down because that was in my little help over here. All right, there we go. All right, another example, but I'm going to do it on paper. I like this example because it ties together some other units, which is fun. All right, here we go. Here's another one. Let's see. So I don't have metals here, okay, but let's see what I can figure out so far. Okay, I know this is electrolytic, okay, because I see a battery. Let's see. I don't have metals, so I can't use table J, so let's look at what other information I have. This says in test tube 1, do you see this? I have electrons on this side. That's this way, right? So that's Leo. So that's losing electrons in test tube 1. So test tube 1 is Leo, right? Which means that is the anode. That is where oxidation is happening. Okay, so let's see, on the other one, we have a gain of electrons, so that's gaining electrons, so that would have to be the cathode, which would have to be reduction. Because of the battery, the anode is not negative, reverse, it becomes positive, and the cathode is negative, but here we are losing electrons, here we are gaining electrons, okay? So let's see what else we need to do. So oxidation and reduction, yes. Identify the information in the diagram that indicates this system is an electrolytic cell. Well, there is a battery in the circuit, right? That tells me it is electrolytic. Determine the change in oxidation number of oxygen during the reaction in test tube 1. Okay, so oxygen is a 0 on this side because it's a single element, and on this one it would be -2. So it changes from -2 to 0. Explain in terms of the products formed in test tube 2 why litmus turns blue in test tube 2. Okay, so let's look at our products right here. And then let's just open up to the reference table dealing with indicators. Right here. Okay. Litmus. When does litmus turn blue? When the pH is above 8.3. So that means it's a base. So what in the products? Oh, so let's see. OH negative is one of the products, and bases have more OH negative. Litmus turns blue in bases. All right, so there we go. And here is our last example, which again, I'm going to do on paper. All right, here's another electrochemical cell. Let's see if we can label as much in the picture before we get to the questions. So see this battery? That tells me this is electrolytic, right? I have 2 electrodes. They're already labeled, okay, as anode and cathode, and it already did tell me that the cathode is negative and the anode is positive, so it already told me this. What I need to know is that reduction happens at the cathode, oxidation at the anode, so this is gaining electrons, this side is losing electrons. Electrons flow from anode to cathode, so the electrons would be going this way. Okay, and since it's gaining, we have mass and atoms going up, but ions going down. And on this side, since we're losing electrons, the mass and atoms goes down, but the ions goes up. All right, let's see if those things help me at all in answering this question. When the switch is closed, which electrode will attract the sodium ions? Okay, so let's look. Here is sodium ions, right? Sodium ions are positive. So sodium ions will be attracted to what? To the negative electrode, right? So that would be the cathode. What is the purpose of the battery? To force the redox reaction to occur, right? Because without the battery, it's not spontaneous. And write the balanced half reaction for the reduction. Okay, so the reduction over here. Reduction is gaining electrons. And if you, all right, so we're gaining electrons. Here is the reaction. I have to start with the stuff over here and end with the stuff over here. So let's look at a number line just to be sure. So we have 0, 1, 2, -1. Okay, sodium was +1, chlorine is -1. They're both 0 on this side. So sodium went from +1 to 0, that was Na, and Cl went from -1 to 0, that was Cl. So which one is reduction? So reduction is at the cathode, and remember, going this way is Leo, and going this way is Gr, so that's Na, right? So Na started with Na +1, gained an electron, and it was just 1 electron to Na. Is that balanced? 1 Na, 1 Na, +1 plus -1 is 0, and 0 on this side. So voila, there we go. And there we have electrolytic cells. Remember, not spontaneous, forced by a battery. I hope you learned something new today.